Hi class, we continue with geometry, circle theorems. I started this in lesson 10 and now we are in lesson 11. All right. So what I decided to do is, here is the theorem and here is the problem that related to this theorem. So you need to understand the theorem, then you'll be able to understand how we solve the problem. All right. So as I said in lesson 10, when we talk about theorem in geometry, it's a principle. Yeah, it's a rule we apply to solve a geometrical problem, especially when it appears in a diagram. Yeah. Though yeah, there are theorems we can also understand without demonstrating a diagram. But mostly in geometry, we discuss the theorem with respect to what? A diagram, so that you'll be able to visualize what the theorem is all about. All right. So it's like a pattern, it's a picture that you need to be able to remember all the time. Okay. So when we talk about angles subtended by an arc, angles subtended by an arc in the same segment are always equal. So you need to understand what is meant by the word subtended. I explained that one in lesson 10. I advise you visit lesson 10. Angles subtended by an arc in the same segment. What is a segment? Yes, these angles are equal. All right. This one is a circle. Clear? Now, if I start from this point, I get to the starting point. This one is a circumference. But if I start here, I intend to stop here. This is an arc. So note that an arc is part of a circumference. The only difference is that the circumference completes the circle. Yes, I keep going. I keep going. Wherever I stop, if I don't get to the starting point, it is just an arc. But if I start here, I get to the starting point, it is now what? A circumference. All right. So now we understand what an arc is. Now um, let's say we have an arc from here to this point. Yes, let me just identify it. We have an arc here. I hope this one is clear. So when you have this arc, note that this other remaining part is also an arc. But this arc is, we call it what? The major arc, because it is longer. You can see lengthier than this one here. Okay, so this arc is a minor, this arc is a major, but that is not the point here. The point here is this one is an arc. So if you connect the 2 points on this arc, we have a straight line. So any line that touches 2 points on the circumference, a straight line touches 2 points on the circumference, is what we call a chord. So this line is a chord. This one is a chord. I hope this one is clear. So whenever you have a chord, the chord always divides the circle into two parts. Yes, this is also a chord. Why is it a chord? A chord is defined as a straight line that touches 2 points on the circumference. This one is a chord, this one is a chord. The difference is that this chord passes, we assume, this chord passes through the center, and this chord does not pass through the center. Because the chord passes through the center, the reason this chord is uniquely called a diameter. This chord is a diameter because it divides a circle into two equal halves. This chord does not divide the circle into two equal halves, so it is just a mere chord. So is chord a diameter? No. Is a diameter a chord? Yes. A chord is not a diameter, but a diameter is a chord. Yeah. For a straight line to touch 2 points on the circumference, that makes it a chord. Does it pass through the center? No. Is it a diameter? No. This one touches 2 points on the circumference. Is it a chord? Yes. Is it a diameter? Yes. Why? It passes through the center. So when we have a diameter divides a circle into two parts, chord divides the circle into two parts, but because it does not pass through the center, this is not this and this are not equal. Because it passes through the center, this and this are equal. So therefore, we call this a semicircle. We call this a semicircle because half of a circle. All right. So Now, this one is a chord. It divides the circle into two parts. So this part is called segments. This part is also called segments. I'm trying to derive at why they are saying in the same segment. We need to understand the word segment. Segment is one of the two portions formed by a chord. Here is a segment, here is a segment. All right. Now, this chord that connects this chord you see here that connect the 2 points on the arc. Arc is our focus here. Angle subtended by an arc. Look at the arc. So let's say this arc forms angle here. See, this arc forms an angle here. We are in that major segment. We have this minor segment, we have this major segment. Remember, a chord divides the circle into two portions. We have this portion, we have this portion. Now, within this portion we call segment, this arc forms an angle. When an angle is formed by two lines, but those lines are coming from an arc, we say the angle is subtended by an arc. All right, so let's call this angle X. Now the same arc forms another angle here. Yeah, another angle here, but we are within the same segment. Let's call this angle Y. So we can see that this arc forms, this arc generates the lines that form this angle. This arc generates the lines that form this angle, and both angles are within the same segment. This is what the theorem is all about. Angles subtended by an arc in the same segment, these angles are always equal. So therefore, this and this are equal. X is equal to Y. So if we can see it here now, look at the arc. This arc forms this angle. This arc forms this angle. So this angle and this angle, they are equal. This is what this theorem is all about. I hope you get it right. All right. So let's see how we solve this problem now. See what we've learned and see what we see in the examination. Yeah, this is what we have in the exam. So you can see that. Why is it so complex? The examiners will not give you the exact thing you learned because this is just the theorem. This is what is given to you to understand the concept. So they have to choose it depending the level, whether it is Becker, IGCSE, whether it is AS level, whether it's SAT, UCE, or you name it, whether it is JAMB, NECO. It depends the exam you are preparing for. So let's see here. Now we have this angle. Sorry, we have this circle here. Yes, but we are given 62:44, 62 degrees 44. But the thing is, try to understand the angles you want to find. Yes. Now let me just have the diagram here. We have this. Yes, we have this one. So this comes to this. This comes to this. Yeah, don't mind the straightness. Okay, so we have here D, C, A, B. We want to find angle BAC. All right, so I'm sorry, there is a line here. I just made the correction. Okay, we want to find angle BAC. Angle BAC. So this is the angle we want to find. Okay, there's supposed to be a line here. Angle BAC. We want to find this angle. Yes. And also angle ABD. Angle ABD. We also want to find this angle. But the angles that are given here are 62 and 44 degrees. We want to find this angle, we want to find this angle. What do we do? First of all, how do we even determine the theorem that is suitable here? Okay, so what we do here is, let's start with the first one, BAC. BAC. See, BAC. This symbol means angle. Yeah. So this BAC simply tells you that two lines, one coming from B, another coming from C, they meet at A to form the angle. BAC. There are two lines that always meet, two straight lines always meet to form an angle. One is coming from B, another is coming from C. They meet at A. So let's see. From B and from C meeting at A. From B and from C meeting at A. So the fact that you know that this A is formed by two lines, one coming from B, another coming from C. See, B, C, B, C. Look at them. See, look at them. Do you see that? So that tells you that we are considering this arc. We are considering this arc. Do you see that? Yes, because B and C, lines from B and C meet at A to form the angle that we want to find. So this is B, this is C. They meet here to find this angle that we want, to form this angle. All right. So if this is the angle we want to find, and line from B, line from C, now we can consider this arc to be a point of discussion here. Yeah, this is our concern now, this arc. So let's see. This arc meets here from this angle. This arc generates the line starts from this. Try to see what which other angle that is formed by what? The same arc. This arc, this one, this arc, this one. But when you take a look at this arc here, look at the line. Look at the line. I'm sorry to extend it. Look at the line here. You can see that this is a chord. Remember, a line that touches 2 points on the circumference is a chord. So once we have this line here, you can see that here is a segment and the rest of this part is a segment. Okay, so now we have the arc from this angle. We have the arc from this angle. So you can see that this angle and this angle, they are what? They are angles in the same segment. And this is what this theorem is talking about. So these two angles are equal. So therefore, we can say, since we want to find BAC, look at BC. They form this angle A. BC, they form this angle D. So this 62 is equal to this angle A here. All right. So now we say angle BAC, angle BAC here is equal to 62. Yeah, but in geometry, mostly we are interested in knowing the reason you say this is equal to this. The reason you say this plus this equal to 180, this plus this equal to 360. We are always interested in the reason. So what do we say? We say angles in the same segment. Yeah. So I don't want to, I think it's composite. Let me don't even say I think it's composite because not only angles in the same segments are equal. So if you just say this is equal to this, there are so many theorems that portray equality. So you cannot just say this equal to this, just that. What is the reason? Why you decided to say that? So we need the reason. Okay. So all about the reason is quoting the theorem. Okay. So that is what we have. BAC is equal to 62 degrees. So what next? We also want to find ABD. 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 Angle ABD. Angle is located at B. So a line from A line from D meet at B to form the angle. So let's see AD. AD. Okay. Look at AD. You see? Do you see this arc? Let's forget about this now. Arc AD. They meet at where? B. AD meet at B. You see? Look at this. They meet here. But is this the only angle that is generated by arc AD? Look, we have this. Look, this one here. See? This. They form this one. They form this one. So you can see that this ABD, this angle here, yes, and this one here, they are angles in the same segment. How do we even determine the same segment? Because AD is connected by this line. So this line is a chord. Here is a segment, and the rest of this part is a segment. So if the same arc that forms this angle is the same arc that forms this angle, we can say 44 and this one, they are equal. So how do we identify? Okay, this is ABD. So now we can say angle ABD is equal to 44 degrees. What is the reason? Because they are angles in the same segment. So this is what this theorem is all about. Thanks for watching. Don't forget to follow, like, share, and comment. See my next video.